So today's topic will be JavaScript modules. So today's agenda will be, we'll be going through what modules are and why we need to use modules and common types of modules and explanation on that. And I'm going a bit deep on ECMAScript modules today. Everything else, I'm just explaining the basic functionality and the definitions on top. And then what is a module bundler and how does it work? So what are modules? A JavaScript modules is a file that you export and then use it in your other files. So for example, for common features you have, you can't rewrite everything in one JavaScript file, right? So we'll be having another file which contains and handles that explicitly, and then you bring it back again to this thing. Let me show you a small code piece. Now say that you have a user JS and then you need to print name and then print age. Simple as that, nothing else. So what you can do is you can write a JavaScript file with export default and then exporting the functions which you need to be incorporated in the other files. So in main.js, if you want to use that function, what you'll be doing is you'll be importing user and then the functions you have in the user, and through that you'll be able to use that and print and display. So the whole reason why we can use this, the difference between this and this is now the user is being exported default. In that case, we can just you can just use the name of the user itself, but we are exporting the function separately. So in that case, if it's not default, we need to have it inside the curly bracket and we need to export it in this way and use it in this way. If not, it'll just throw an error saying that we cannot find this thing and there's only one export default function class or function in the user.js file. And another thing to mention here is now when we are importing as such in index.html, this is just index.html and a JavaScript file. So over here, if you want to import it, now if you don't have the type modules when you're importing your main.js, it won't be able to figure out what import is, even though JavaScript does it, but you need to mention it in the things. That is the new browser specifications which are required. In the latest browsers, it needs this modules. But if you're using old browsers such as something like Internet Explorer or something, you need to use this no module. That what it will do is in the old script files, it'll run this. Old browsers, it'll run this script file. And then in the latest browsers which handles modules, which will run this file, and vice versa, it'll neglect the other two. So if you want to run something, a different file in the old browser, you can just put no module and use that script. In that case, if this is in the old module, the new script file will not be run at all. It will just neglect it, the complete script and go. So this is just a basic example of how to use and what a module is. And let me go back to the definition. So a file that allows you to share codes with other files within your project. So which we usually use using yarn or npm. So for example, you'll be installing some npm this thing like Google or something like that. And why we need to use modules is when JavaScript came out earlier, the scripting task for only scripting tasks on small functions only, they use JavaScript. But nowadays we are using it for everything. For even a small this thing, we are using JavaScript file. So today, however, JavaScript has gone too much big. So we are using a simple mathematics even, we are using it in another file, keeping it in another file, and we are using it here. The reason is to be formal and to use everything. So since JavaScript is used virtually for any programming task, need rows to share scripts between the project files. So for example, if you want to use some machine learning these things, or if you want to use some calculations which is common and which is heavy, what you can do is write this thing, put it in the npm, and then download it and use it as it is. So there are few common types of modules which are being used. Today I'll be only explaining about these four, and I'll be explaining more on the ECMAScript module detailedly. So as of now, there is a asynchronous module definition, AMD, universal module definition, and then common JS modules, which is being used in Node.js, and then ES modules. So first we'll start with the AMD. So AMD stands for asynchronous module definition, which means to be a pattern of loading modules for front-end projects. So at the early days, we have to write a list of dependencies and then use it based on that. So once a document and all its resources were fully loaded, you could run the code. So it simplified the task of declaring the specific dependencies for your modules and making sure that they will all be loaded before your code would be executed. It also added a major improvement. Instead of having include all your app's dependencies and having them loaded before a single line of code could be executed, this approach made it so you could specifically exactly which dependency to load for which section of the code, and this in turn provided a major performance boost for applications with many external dependencies. In that case, it'll make your application run more faster, but it requires for you to import those dependencies in the specific files and specific places you need to be used. So how the AMD runs is, you have to define the function. So once you define, say that over here for this example, we are just using a load dash and then we are returning a dummy function with just changing it the dummy as camel case. So you need to this way you need to write it so that you define it first and then the function will be there. Inside the function there will be return. Through that return you will be able to access the dummy function. So you need to do the same import as like I showed before. Using that you will be able to use the dummy function and it will give you the this. And this ensures two major issues in front end. All dependencies have been correctly loaded before we run them. So none of the dependencies miss before even we run them. So it will show in the this thing itself. And that our code is running in a safe scope. So in that case, we won't be bringing in unnecessary modules or unnecessary libraries inside which we don't need to be used. And then comes the universal module definition. That is the UMD. Just like AMD, better module for loading pattern, UMD defines a universal module definition. In other words, it tries to provide a way of writing your module in a format that can later be loaded by multiple loaders. Hence the universal part. The reason is, so I'll just keep on explaining then you'll understand. So it's composed of two major parts. One is immediately invoke function expression that receives two parameters, the root, which is reference to the global scope, and the factory function, which is the code of the module. And factory function, it receives dependencies and it can be executed just like with the AMD pattern in a separate scope. Inside the initial IAF, we'll just boilerplate logic and we'll decide which module to be used based on our needs. So this is a sample of how a UMD can be written once it's transpiled by Payable. So you can see the body of the IAFE is checking if AMD is defined. It's looking for the defined function. Then if it isn't, it's looking for the exports keyword to be available. It would be imply we are dealing with a common JS loader. Finally, if none of them are defined, then it will proceed to create a common object that will be assigned to a global scope. Here the global scope is referenced by the global variable when the first parameter is received. Second function, which as you can see contains our example module, remains almost untouched. Only difference is that now receives two arguments and exports one, which is where we'll add whatever we are exporting and load dash containing the dependencies we declare. The body of the IAFE is first checking if AMD is defined. It's looking for defined function and then it's looking for exports keyword to be available. It would imply we are dealing with a common JS loader. Finally, if none of them are defined, then it will proceed to create a common object that will be later assigned to the global scope. Here the global scope is referenced by the global variable. Second function, which is, as you can see, contains our example module, remains almost untouched, and exporting load dash, which is declared. So over here, as you can see, the dummy function is exported and then you can use the dummy function. So the big problem of using this is this pattern might require adding a bit more code to wrap your model. So for example, let me show you, this is what you need to do AMD, but this is how it becomes UMD in order to do the same thing. So it's a bit of a huge wrapper thing you need to write for multiple systems. So in that case, it will be too much coding and too much effort to be maintaining a library. So people tend to not use this, even though it's a good thing and it will be available universally throughout all of these things easily. But the problem is too much lines and extra effort needed to do this. So comes the common JS. Every Node.js developer will be using this in order to do these things nowadays. So as like for Java's other front end, these things we use ECMAScript. Common JS is commonly used for Node.js based on development. Nowadays, ECMAScript is also coming. So now common JS is what the Node.js is using, and then it implements a module in JavaScript, and then it's started by Mozilla engineer Kevin Dungno. Common JS is mainly used for server-side JS applications with Node, as browsers don't support use of common JS. Node used to be only support common JS, and ECMAScript also being used as a modern approach. So you can see the code how it's being used over here. So for the dummy function, we just set a object and then we export the dummy function, require load dash, and then define the dummy function down and export the dummy function and assign it with the defined new dummy function. So it will just export this. And so through exports, you'll be able to import it and get it up and run. So common JS can do different things differently because loading files from file system takes much less time than loading across the internet. This means Node can block the main thread while it loads the file. And since the file is already loaded, it makes sense to just instantiate and evaluate which aren't separate phases in common JS. It happens at once. This also means that we are walking down a whole tree of loading and instantiating and evaluating any dependencies before you return the module. Common JS approach has a few implications, but one thing that it means in the Node with common JS modules, you can use variables in your module specifier. You are executing all of the code in this module up to the require statement before you look for the next module, which means the variable will have a value when you go to the module resolution. So one by one it will check and go. So that's common JS modules. Now we'll be starting with ECMAScript modules. So this is mainly used for front-end development and JavaScript based modulings. This is the basic ECMAScript module definitions. So the connection between two different dependencies come from any import statement that you use. These import statements are how browsers or Node knows exactly what code it needs to load. You give it a file to use as an entry point to the graph. From there, you'd follow if any of the import statement, find the rest of the code. So what you do is you put main.js. Inside main.js, I need to run only the counter.js. So, but on count, inside counter.js, in that case, it will open this and find the count and then do whatever's inside that count. If whenever we have used the count in our main.js, the same goes with the render in display.js also. So, but files themselves aren't something that browser can use. It needs to pass all the files to turn them into data structures called module records. That way it actually knows what going on in the file. After that, the module record needs to be turned into a module instance. So an instance combines two things, code and a state. So code is basically a set of instructions. It's like a recipe for how you make something, but by itself, you can't use the code to do anything. You need raw materials to use it, like the states. So what is a state? State gives you the raw materials. State is actually actual values of the variables of the point in time. So for example, before we had the age and the name, right? So those are the states we maintain in order to this thing inside the code. And of course, these variables are just nicknames for the boxes in memory that hold the value. So the module instance combines the code, list of the instructions with the state, all the variables and values. So this is how it is. So through the function, we'll be getting the state, and then through the code, you'll be able to access that. What we need is a module instance for each module. The process of the module loading is going from entry point file to have a full graph of module instances. So for each module, this happens in 3 steps. 1, construction, then instantiation, and then evaluation. So in the construction, what will happen is it will search for it and then download and pass all the files into the module record. Then find the box in the memory which module to be used, and then from then make both exports and imports, point to the boxes in the memory, and then this is what is called linking. So in that way, it will be linked wherever we want to use. And then evaluation, run the code to file in the box with the variables with the actual value. So for example, in this, we have created the user right over here. So with what happens is in instantiating, it'll go to this point and then tries to find, so it'll add the user with the name and this thing. Then only we'll be able to use this. So in printage, what happens is it'll just get the user.name. So this is what happens in evaluation. So it checks whether it gives this without a problem in the correct way. So that's what the evaluation stage is. So construction, 3 things will happen majorly inside it. Figure out where to download the file containing the modules, that is the module resolution. Fetch the file by downloading it from URL or loading it from the file system, and pass the file into a module record. So it all happens in this line. In just this import line, it will check it and construct it the way we want. And then comes the loader. And then the loader will take care of the finding of the file and download it. First, it needs to find the file where it needs to point, and then you tell the loader by using the script. On part of the import statement, this is called module specifier. It tells the loader where it can reach the next module. So over here, we specify the module specifier. One thing to note about module specifier is they sometimes need to be handled differently between browsers and Node. Each host has its own way of interpreting the module specifier strings. To do this, it uses something called module resolution algorithm, which differs between platforms. Currently, some module specifiers that work in Node won't work in browser. But there is ongoing work to fix this. Until that's fixed, browsers only accept URLs as modules. It only accepts this as modules. They will load module file from that URL, but that doesn't happen for the whole graph at the same time. So for the whole, this thing won't happen at the same time. You don't know what dependencies, what module needs, that the module needs you to fetch until you pass the file. And you can't pass the file until you fetch it. So if you couldn't fetch it using this, it's not going to pass. So when it's passing only, you'd get the dependency. So that's a small note you need to keep in mind. So if the main thread were to wait for these files to load, a lot of other tasks will pile up in its queue. That's because when you're working in a browser, downloading part takes a long time. Blocking the main thread like this would make an app that uses modules too slow to use. This is one of the reasons why ES module spec splits the algorithm into multiple phases. Splitting into construction into its own phase allows browsers to fetch files and build up their understanding of module graph before getting down to the synchronization of working instantiation. This approach, having an algorithm split into phases, is one of the key differences between ES modules and common. Common module does not do this. It will load exactly as it is, because at once it loads everything together. But in ES modules, it loads us differently, as I showed before. This means we have to go through the tree by tree layer, passing one file, then figuring out its dependencies, and then finding and loading those dependencies along with the values. But with ES modules, you are building up this whole module graph beforehand. Before you do any evaluation, this means you can't have variables in your specific module specifiers, because those variables don't have values yet. So we are the passing step. But sometimes it is really useful to use these variables for module paths. For example, you might want to switch which module you load depending on what code is used, what code is doing, or what environment it is running, right? So for example, over here in this, you need to find which path is, but this won't be able to use with the import statement. To make this possible ES modules, there's a proposal called dynamic import. With it, you can use import statement like import. The way this works is that any file loaded using import is handled as entry point into a separate graph. So it will go as a different graph, and then over there it checks for the path and the assignment. Then the dynamic imports a new graph which processes separately. One thing to note over here though, any module that is in both of these graphs is going to share module instance. This is because the loader caches the module instance for each module in particular global scope. There will be only one module instance. This means less work for the engine. For example, if it means module file will only be fetched once, even if multiple modules depends on it. That's one reason to cache modules we'll be seeing in the evaluation section. The loader manages this cache using something called a module map. Each global keeps tracks of these modules in separate module map. When the loader goes to fetch the URL, it puts that URL in the module map and makes a note that is currently fetching the file. Then it will send out the request and move on to start fetching the next file. So module map will be, it will just go to wherever you have mentioned it and then fetch it. So what happens in another module map depends on the file, same file. The loader will look up for each URL, the module map. If it's fetching in there, then it will just move to the next URL. It won't again fetch once it's fetched at once and cached. But the module map doesn't keep track of what files are being fetched. Module map also serves as cache for modules. So pass it. So now that we have fetched this file, we need to pass the file into a module record. This helps the browser to understand what different parts of modules are. This one detail in passing that may seem trivial, but the actual has a pretty big implication. All modules are passed as if you had used strict techtalk. There are also other significant, other slight differences. For example, the word await is reserved in the module top level code, and the value of this is undefined. This difference is way of passing is called pass goal. If you pass the same file but use a different goal, you'll end up with a different result. So you want to know before you start passing what kind of file you're passing, whether it's a module or not. Once the module record is created, it is placed in a module map. That means whenever you are requested from here on out, the loader can pull it from that map. So at this point, module map is loaded. And so whenever you want, you can just use it through the module map. And whenever it's required, you can use it as it is instead of going again and fetching it, loading it back again. So in browsers, this is pretty easy. Just type module on the script tag as I showed before. This tells the browser that the file should be passed as a module. Since it's only modules can be imported, browser knows that imports are modules too. So as I showed you before in this example, in the index.html, we need to set it as modules. In that case, it knows that this is exported as a module. So we need to handle whatever is inside main.js as a module. So, but in Node, you don't use HTML tags, right? So you don't have an option to using type attribute. One way community has resolved this is by adding MJS extension. Using that extension tells you know that this file is a module. So instead of JS, MJS. You'll see people talking about this as a signal for pass code. The discussion is currently going, so it's unclear what the signal Node community will decide to use at the end. Either way, the loader will determine whether to pass the file as a module or not. If it's a module and there are imports, it will then start the process over again until all of the files are fetched and passed. Now comes the last part, instantiation. Now, like I mentioned before, an instance combines code with state. The state lives in a memory. So the instantiation step will be all about wiring up things up to the memory. First, the JS engine will create a module environment record. This manages variable for the module record. Then it finds the boxes in the memory for all exports. The module environment record will keep track of which box in memory is associated with each export. These boxes in memory won't get their values Yeah, it only happens off evaluation when the actual values are being filled. There is one caveat to this rule. Any exported function declaration are initialized during this phase. This makes things easier for evaluation. Instantiate the module graph. The engine will do what it's called depth first post order traversal. This means it will go down bottom of the graph to dependencies at the bottom that don't depend on anything else and set up their exports. The engine finishes wiring up the exports below the module, all of the exports that the module depends on, then it comes back up to the level wiring up. Imports are from that module. Note that the both exports and imports point at the same location in the memory. Wiring up the exports first guarantees all the imports can be connected in the matching exports. This is different from CommonJS modules. In CommonJS, the entire object is exported, copied in on export. This means any value like numbers that are exported are copied. This means that if exporting a module can change the value later, the importing module doesn't see the change. So once copied, it's copied. Now, once ever this thing, you need to completely rerun this back again in order to see a CommonJS module change. In contrast, ES module use something called live binding. Both modules point to the same location in the memory. This means when the exporting module changes the value, that change will show up in the importing module as well. Modules that export values can change those values at any time, but importing modules cannot change the values of the imports. That being said, if module imports an object, it can change the property values that are on the object. The reason to have live bindings like this is when you wire up all the modules without running a code, this will help the evaluation when you have a cyclic dependency, as I'll explain below. So at the end of this step, we have all of the instances and memory locations for each import and export wired up. Over here, you'll be able to see that it won't update the module once this thing is up. So it'll export, and then once the exported values change correctly, then only it'll get. So over here, cyclic dependency problem comes is at this point, this module set does not have the value updated, right? So even though this changed and this has the value correctly, currently this dependency will fail because this is being changed at that point. Now comes the evaluation. Final step is filling these vectors in memory. JS engine does this by executing the top level code, the code that is outside the functions besides just filling these boxes in memory. Evaluating the code can also trigger side effects. For example, a module might make a call to server. Because of the potential for side effects, you only want to evaluate the module once, as opposed to linking that happens in instantiation, which can be done multiple times with exactly the same results. Evaluation can have different results depending on how many times you use it. This is one of the reasons to have the module map. The module map caches the module by canonical URL so that there is only one module record for each module. That ensures each module is only executed once, just as with instantiation. This is done as a depth first post order traversal. In cyclic dependency, you end up having a loop in the graph. Usually this is a long loop, but to explain the problem, I'm going to use a contrived example with a short loop. So over here, we define this thing and then we have a message. The message export hasn't been initialized yet. So the local message variable at the counter.js gets set to undefined. So whenever we try to use this, it will be in a cyclic this thing trying to go back and check whether the value is updated or whether it's defined and initialized back again. So let's look how this would work in a CommonJS module. First, main module will be executed up to the required statement. Then it will go up to load counter. The counter module would try to access the messages from the export object. But since this hasn't been evaluated in the main module yet, this will return undefined, and the JS engine will allocate space memory in memory for the local variable and set the value to undefined. So evaluation continues down to the end of the counter module, stop level code. We want to see whether it will get the correct values for message eventually after main.js is evaluated. So we set up a timer, then evaluation resumes on main.js. The message variable will be initialized and added to memory. But since there is no connection between the two, it will stay undefined in the required module. If the export be handled using live bindings, the counter module would see the correct value eventually. By the time the timeout runs, main.js evaluation would have completed and filled the value back again. And then comes with the bundler. So once you do a module, then you need to bundle it. So module bundler is a tool developers use to bundle the apps modules dependencies into a single browser compatible JavaScript file. The module bundlers allow browsers to access the file you specified in the require or import statement. In other words, suppose a browser runs a JavaScript file with a require statement. In such cases, the browser will throw an error saying that uncaught reference requires not defined. The computer will throw such errors because the browser cannot access the file specified in the JavaScript program. However, you can use the module bundler to create a new JavaScript file containing the code which the browsers can read. So once this bundling is done, then only you can upload to, I mean, say for example, you need a public NPM or private NPM, you can upload the bundled this thing into the NPM, and then you can directly use as it is instead of just trying to import the application app.js. You can just put a name like saying that sample app or something, and then you can just import it using active method itself, like the traditional NPM imports we use. So that's about it on JavaScript modules. Things, if you have any doubts or anything, let me know.